August 24, 2006. A sad day, a dark day. The day Pluto got degraded to Dwarf planet. From then on, there were only 8 planets in the solar system. People were disappointed, even a bit outraged, that the little brother of the solar system was no longer considered good enough to be a planet. There was so much discourse that to Pluto something was awarded Word of the Year by the American Dialect Society. I didn't even know the American Dialect Society existed, but here we are. I was 17 back then, and I clearly remember Pluto being demoted to Dwarf planet and reading about it in the paper and hearing about it on the news, and I remember thinking to myself, what is happening? What are they doing? But I read the explanation and I figured it made a lot of sense, actually. The International Astronomical Union had decided on a new definition for what a planet is, and Pluto simply didn't meet the requirements. In the solar system, a planet is a celestial body that is in orbit around the Sun, has sufficient mass to assume hydrostatic equilibrium, so basically the object has to be massive enough so it becomes rounded, and has cleared the neighborhood around its orbit. Pluto meets the first 2 criteria, but not the last one. Pluto resides in the area beyond Neptune called the Kuiper Belt, and it consists mainly of small icy objects such as a bunch of other dwarf planets and asteroids, remnants of when the solar system formed. Pluto isn't big enough to clean these objects out of the way as it orbits the Sun, so sorry buddy, not a planet. And so textbooks were changed, and scientists, science communicators, and teachers everywhere taught about this new class of object called a dwarf planet, with Pluto as the main example, to this day. It will probably surprise you that many planetary scientists, people who dedicate their time to the study of not only planets and dwarf planets, but moons and asteroids as well, do not agree with the IUA's definition. They think the decision was made a bit rushed and sloppy, and is even a bit unscientific. Defining what a planet is and isn't is still a topic of debate, and the meaning of the word planet has historically changed and will probably change again in the future. As an intelligent species, humans have studied the night sky for ages, although we will likely never know exactly when humans started to notice and keep track of the motion of objects in the sky. Early cultures linked the sun and moon, the planets, and the constellations to the divine, gods and spirits, and so the earliest astronomers were likely priests of some kind. They kept track of the stars and the seasons, and it was commonly believed one could predict the future this way, and so early astronomy was deeply intertwined with astrology, the belief that stars and planets have an influence on our lives here on Earth. The word planet comes from Greek planetes and means wanderer. The ancient Greek and many other ancient cultures kept track of the planets visible to the naked eye. Mercury, Venus, Mars, Jupiter, and Saturn. But since the Sun and the Moon also wander across the sky, they were also considered planets. While there were some that proposed a universe where the Earth and the planets revolved around the Sun, the most commonly accepted model was geocentric. The Earth sat motionless and perfect at the center of the cosmos, and all the planets went around it in perfect circles. This idea remained unchallenged for thousands of years, and it didn't help that the Catholic Church in Europe considered questioning the perceived perfection of the heavens as created by God to be heresy. This is how it works. Don't ask too many questions, don't be difficult, we will set you on fire.
Nobody expects the Spanish Inquisition!
In 1543, astronomer Nicolaus Copernicus set a revolution in motion when he published his heliocentric model of the cosmos. But at the time it was dismissed and largely swept under the rug because it was impossible to prove with just naked eye observations. This all started to change when Galileo Galilei designed the first telescopes meant for astronomical observations in the early 1600s. Galileo observed the moon, and instead of a perfect sphere, which was what people believed the moon was at the time, he saw it was geologically diverse and had many mountains, valleys, and craters, just like Earth does. He discovered the 4 big moons of Jupiter, Io, Europa, Ganymede, and Callisto. And he discovered Venus has phases just like the moon does. For Galileo, this was enough to prove that heliocentrism was correct. He fell out of favor with the church for teaching his discoveries, however, and spent the last 9 years of his life under house arrest. But many other astronomers made the same observations, and so heliocentrism became more and more popular until it was completely accepted. The Earth became one of the many worlds in the solar system, instead of the perfect center of a perfect cosmos. And to be clear, the moons of Jupiter and the newly discovered moons of Saturn were also considered planets by the old astronomers. They had no reason to think of a moon as something non-planetary. After all, Galileo had discovered that the moon, just like Earth, is a complex world with features similar to our own planet. This idea was pivotal in the dismissal of geocentrism and the acceptance of heliocentrism. Earth is just another planet, very similar to the other ones, in orbit around our Sun. 1781 was a great year for astronomy because for the first time ever, a new planet was discovered in the solar system, Uranus. Now, Uranus had been observed since ancient times. If you have very good eyesight and access to the darkest skies, it's actually visible to the naked eye, but due to its slow orbit of 84 years, it had never been recognized as a planet. Over the next few decades, several moons of Uranus were discovered. Between 1801 and 1808, 4 new worlds were discovered in the solar system. Ceres, Pallas, Juno, and Vesta, all orbiting between Mars and Jupiter, in what we now call the asteroid belt. In those days, astronomers referred to these small objects as small planets, minor planets, and asteroids, and they considered them to be a subset of planets, much like, for instance, horses are a subset of mammals. Keep in mind that these small objects appear like tiny dots in a telescope. There was no way anyone could guess what they actually looked like. Even with the best telescopes of today, all you can see is vague grey blobs, and we have to send probes to these asteroids and the planets and moons to be able to study them properly. Back in the 1800s, these 4 asteroids were often included as planets alongside the big planets in astrological texts that were popular among the public. Sometimes the Sun and Moon were also still listed as planets in the same way the ancient Greek classified them. Since astrology was one of the few ways the general public had access to astronomical information, it's likely that people considered these 4 asteroids to be planets and that they believed there were at least 10 or 11 planets in the solar system, including or excluding the Sun and Moon, depending on who made the astrology books. However, over time, the Sun and Moon became their own separate thing. The Sun is a star and the Moon is, well, the Moon. While scientists considered all worlds orbiting the Sun to be planets, whether they were major planets, minor planets, or satellites, popular astrology only bothered with the major worlds of the solar system, and so people generally weren't aware of all the existing moons and asteroids. And I don't think I need to say this, but astrology is pseudoscience. The stars and planets do not have any effect on anyone's personality or walk of life. In 1846, the planet Neptune and its biggest satellite Triton were discovered. For the rest of the century and the start of the next, astronomers hunted for the next planet. It just had to be out there. They also found more and more asteroids in the asteroid belt. And by the 1920s, over 1,000 asteroids had been found. The findings accelerated by the discovery of photography and its application in astronomy, which was extremely helpful in finding very small and dim objects in the night sky. In 1930, it finally happened. A new planet was discovered beyond the orbit of Neptune. It was named Pluto, and initially it was believed to be roughly the same size as the Earth. Pluto has a very unusual orbit, elongated and tilted, and in a dance with Neptune so that Pluto orbits the Sun twice every 3 times Neptune does. Occasionally, Pluto's orbit takes it closer to the Sun than Neptune, but the 2 planets are never near each other in space, nor will they ever be. Over time, the estimates of Pluto's mass shrank, and now we know it's only 0.2% of Earth's mass. By the 1950s, astronomers started to realize how asteroids were formed differently than planets, and weren't really a subset of planets, but in a category of their own, and so they were no longer referred to as minor planets. Most people alive today grew up learning there are 9 planets in the solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. Now, something else happened in the first half of the 20th century, something you could refer to as the Great Depression of planetary science. Astronomers, for the most part, became less and less interested in studying planets. Now, there was the economical Great Depression of the 1930s and 2 world wars, so funding for astronomy and a lot of scientific research in general was reduced. And also, the main technologies used for observing planets, such as telescopes, were reaching their physical limits already at the end of the 19th century. There just didn't seem to be a lot of new things to do with planets. And yeah, Pluto's discovery was a pretty big deal, but aside from that, astronomers mostly focused their efforts on other stuff. like the discovery that many of the nebula in the night sky were other galaxies, and that the Milky Way is just one of those many galaxies. There was a study of stellar evolution, radio astronomy was discovered, there were major advances in the fields of nuclear physics and astrophysics, and Edwin Hubble found that the universe was expanding at an accelerating rate, which was an absolutely mind-blowing discovery at the time. And so studying planets and discovering yet another distant space rock seemed a bit dull in comparison, so most scientists simply didn't bother. But this would completely change with the age of spaceflight. Starting in 1959, we began to visit other planets, moons, comets, and asteroids with spacecraft. Instead of dots of light in a telescope or on a photographic plate, planets became places. You could send robots or even people there, take pictures, bring samples back to Earth for study. And so it wasn't just astronomers that could study planets. Now, geologists, physicists, atmospheric scientists, and so on could study the features and the inside and outside complexities of other worlds, and compare them to Earth and each other. With this resurgence of the popularity of planetary science, scientists continued referring to moons and dwarf planets such as Pluto as proper planets. But this idea didn't really spread beyond the field of planetary science. You'll remember I talked a bit about astrology for the masses before, and that over time the sun and moon became like separate entities alongside the other planets. Obviously, for the sun this makes total sense also from a scientific point of view. The sun is a star and has very different properties than a planet. For one, nuclear fusion is the main thing that sets stars apart from planets. But for some reason, the distinction that stems from astrology stuck better for most other scientists, and this idea remained popular with the public. You have the major planets, 9 down to 8 these days, and then moons and other stuff. This may be because of the Great Depression of planetary science. You had a whole generation of scientists coming of age during a time when not many people were interested in studying planets, so they sooner learned ideas about planets and moons that ultimately stem from astrological tradition instead of proper scientific thinking. And these ideas were taught to the general public as well. It's hard to pinpoint when and why exactly this happened, but this idea that moons are another class of object does not come from scientists. And so there seems to be this odd disinterest in moons if it isn't our own moon. People know the 8 planets of the solar system, but moons are generally not that well known or talked about all that much. The old astrological ideas still seem deeply ingrained in people's minds. There's only a handful of planets, moons are something different, and since Pluto's degradation, dwarf planets are something different again. But for planetary sciences, these distinctions don't really matter. And just so you know, if a scientist is mostly interested in studying moons, they're still very much a planetary scientist. Now, if you're thinking, okay, if we really have to start referring to all these balls in space that are not stars as planets, won't that be confusing? Obviously, you can still apply all the different categories we use today. Terrestrial planets such as Venus and Mars and our own Earth, gas giants such as Saturn and Jupiter, ice giants like Neptune and Uranus, and dwarf planets, and planetary mass moons. But for planetary scientists, all of these, albeit useful distinctions, fall under the greater umbrella term planet. There is no logical scientific reason to have only a few proper planets and consider moons and dwarf planets to be something different entirely. So we can re-examine the definition of planet from the IAU's decision in 2006. 2 of the 3 criteria are focusing on an object's orbit, but planetary scientists have since argued that orbit isn't a good criterion for classifying an object. Technically, moons are also in orbit around the sun, they're just being dragged along by the bigger planets. Here's a fun fact for you, the moons Titan and Ganymede are actually bigger than the planet Mercury. Also, what do you do with exoplanets and rogue planets? Exoplanets orbit other stars, but they're still very much planets, and rogue planets got ejected from their systems for some reason, but they can still be geophysically complex. If tomorrow a rogue black hole flies through the solar system and Earth gets yeeted into deep space, is it then no longer a planet? You get the idea. By the way, the IAU didn't decide to demote Pluto just because. Since the 1990s, more and more new small objects have been discovered in the Kuiper belt beyond Neptune. A lot of these are like siblings of Pluto, and are similar in size and composition. And so astronomers started to wonder, do we consider these things planets, or are they a different kind of object? And so in 2006 they arrived at the current official definition of what a planet is, and classified Pluto and similar objects as dwarf planets, which are not planets, even though the word planet is right there in the name, so it's a bit confusing once you start to overthink it. Anyway, like I said, planetary scientists tend to disagree, especially with criteria 1 and 3 of the definition. They say that the orbit of an object is not that important and that the definition should depend a lot more on the physical properties of an object in space. So what does that mean exactly? Criteria number 2 is the only one of the 3 in the IAU's definition that actually focuses on an object's properties. It must be in hydrostatic equilibrium, so more or less ball-shaped. I say more or less because the very smallest moons and dwarf planets are a little wonky, and as a matter of fact, even the bigger planets are not perfect spheres, but tend to bulge out a bit at the sides because they spin. Still, general roundness. And of course, if the object is so large nuclear fusion starts to happen in its core, it's not a planet but a star. So that's the upper cutoff for planets. The lower cutoff is a bit muddier and depends on an object's mass and composition. Small, low-mass objects like asteroids are lumpy piles of rock and ice and often have large empty spaces between their component blocks. In larger objects, generally starting between 400 and 600 kilometers in diameter, gravity crushes the object under its own weight, getting rid of the empty spaces and smoothing the object into a ball. An object that is mostly made of ice will crush itself and become round at a smaller diameter than a world mostly made of rock, because ice is weaker than rock. Saturn's tiny icy moon Mimas is about 400 kilometers in diameter and is likely the smallest rounded object possible. But then there's also Neptune's icy moon Proteus at 420 kilometers, slightly larger than Mimas, but it's not exactly rounded. The asteroid Pallas is at 510 kilometers, the smallest rocky world that appears to be nearly round. But roundness isn't the only criterion for a planet. Starting at that size, the object becomes geologically active due to internal heating and can have a complex layered internal structure. And this is another thing that sets it apart from asteroids. Asteroids are also too small to hold on to an atmosphere, but bigger objects tend to have atmospheres. Pluto has an atmosphere, and so does Ceres, one of the smallest known dwarf planets and the closest one to Earth. Other planets and many moons have atmospheres, volcanic activity, they may have subsurface oceans which may even host life, and so on. Big planets are massive enough to gather large amounts of ices and gases as they formed. Their materials are squeezed to extreme pressure at high temperatures. These worlds may have no solid surface at all, moving from gas to liquid to more exotic high-pressure forms of matter deep inside them. Their materials create powerful magnetic fields. And so planetary scientists argue that a definition for planet should focus on geophysical and geological properties. A planet is a condensate of intermediate size where physics produces complexity in geology, mineralogy, chemistry, and possibly atmospheres, oceans, magnetospheres, biology, and more. A planet is an object large enough for gravitational rounding, but not big enough that it ignites fusion in its core, regardless of its orbit. Scientists of the past discovered the planets were other worlds, much like Earth, special places throughout the cosmos where complex physical phenomena happen similar to those of our home world. The likes of Galileo, Kepler, Cassini, Huygens, Herschel, and so on always defined planets to include both major planets and their satellites, and there is no real scientific reason to limit the amount of proper planets based on where they orbit, or that they must be low in number. And so you can honestly say there are at least 30 planets in our solar system, including Pluto, of course. There's Mercury and Venus, our Earth and Moon, and Mars. If you've been paying attention, you know why the moons of Mars are not included in this list, because they're clearly asteroids that got caught in an orbit around Mars. Moving on to Ceres, the only official dwarf planet in the asteroid belt, and possibly Vesta, Pallas, and Hygeia as well. But at this time there isn't enough information on these objects to say if you can classify them as dwarf planets. Of course, Jupiter and its 4 big moons, Io, Europa, Ganymede, and Callisto. Saturn and its satellites Titan, Tethys, Dione, Rhea, Iapetus, Enceladus, and Mimas. Uranus and its moons Titania, Oberon, Ariel, Umbriel, and Miranda. Neptune and Triton, and maybe even Proteus. Beyond Neptune in the Kuiper belt we have Pluto and its largest moon Charon, and the dwarf planets Eris, Makemake, and Haumea, all confirmed to be rounded. Although Haumea is more egg-shaped because it spins very fast, that's still pretty much round. Welcome back, Pluto! We missed you, buddy! But wait, there's more. There's 6 objects in the Kuiper belt that are known to be big enough that their roundness is virtually certain. Gongong, Quar, Sedna, Orcus, Salacia, and 2002 MS4. Yeah, that last one hasn't been officially named yet. Oh, but we're not done yet. There's 17 more bodies that are probably more than 600 kilometers in diameter and so are very likely to be round, only a few of which have been officially named. And then there's even more potential planets. Over 100 that are estimated to be in the size range between 400 and 600 kilometers in diameter, many, but not all of which might be round. I can hear you thinking, hang on, does that mean there's possibly 160 planets in the solar system? Yeah, that's exactly what I'm saying. Isn't that exciting? You get Pluto back as a planet and then some. And then a lot more. Okay, but to be fair, most of these are not well studied because they are very, very far away, all the way out there at the outskirts of our solar system. So you can shorten the list for now to about 36 planets, moons, and dwarf planets. And now maybe you're thinking that's still a lot compared to the much shorter list of 8 planets we have now. Are people gonna bother to remember that? Are children in school gonna wanna learn 36 planets? If you ask me, sure, why not? Children need to remember a lot of other things. In the US, children need to learn the 50 states of the country. I live in Belgium and growing up I had to learn all the countries of Europe and their capitals, and that's a list of 88 things in total. And that's just geography. Kids learn so many things all the time and they can remember them long term. And the same goes for adults. Most jobs require a person to remember a fair amount of things. It's just life. When I was a kid, I had a poster in my room above my desk with the original 150 Pokemon, and I would stare at it all the time, especially when I was supposed to be doing homework. And I knew every single one. Maybe someday in the future we can have posters of 36 or more planets in kids' rooms. So even if the list of planets in the solar system would grow to over 100 confirmed planets, the number of them doesn't really matter. What this video tries to get across is that the planetary scientist community are still calling for a logical, scientifically sound definition for what a planet is. And if there's 8 or 108, the amount shouldn't make a difference in how science is practiced and how it's being taught to the general public. And a skeptic might say nobody cares about moons and dwarf planets, but you can absolutely make people care. I mean, so many people would love to see Pluto restored to proper planet status. You can teach kids that Mimas looks like the Death Star from Star Wars, that Iapetus looks like vanilla ice cream dunked in chocolate sauce, that parts of Triton look like a cantaloupe melon, that if you had a very special diving suit, you could go swim in the lakes of Titan, that Miranda looks like a giant tore it into bits and then messily put it back together again, that Io is yellow from all the sulfur from its volcanoes, and it probably smells like rotten eggs, and farts. Kids are gonna be fascinated by that, especially if it involves farts. And like I said before, the categories rocky planet, moon, ice giant, gas giant, and dwarf planet are absolutely useful for teaching and memorizing. In the end, every planet in our solar system and beyond is endlessly fascinating. The volcanoes of Io, the geysers of Enceladus, the lakes and rivers of liquid methane on Titan, the deep subsurface oceans of Europa, the diverse terrain of Triton, the mangled face of Miranda, the mountains of our moon, the clouds and canyons of Mars, the thick toxic atmosphere of Venus, the magnificent swirling storms of Jupiter. Every world in our solar system is a shining jewel in the string of pearls our sun wears on its journey through the cosmos. So if you want to call Pluto a planet again, there you go. It's valid science. Thank you for watching. I hope you learned something new today, and I will see you soon.